Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 29, Key Management and Rotation. Last episode, we covered encryption at rest and in transit. This time, we're talking about the keys themselves. Alice, why does key management matter if the encryption is already strong?
Because the encryption algorithm is only half the equation. Think of it this way. You've installed the best lock money can buy on your office door. AES 256, military grade, unbreakable. But then you tape the key to the door frame. The lock is perfect. The security is zero. That's what happens when you encrypt data but store the encryption key in the same database, or hard-code it in your application, or put it in a config file next to the code.
So the key needs its own protection.
Exactly. And the way modern systems handle this is through something called envelope encryption. Picture a chain of locked boxes. You have your actual data, say a privileged client communication in your case management system. You generate a fresh key just for that document. That's your data encryption key, or DEK. You encrypt the document with the DEK. Then you take that DEK and encrypt it with a separate, more powerful key called the master key. The encrypted DEK gets stored alongside the encrypted document. The plaintext DEK is immediately destroyed.
Right. So even if someone steals the database, they get encrypted documents and encrypted keys. They can't do anything with either one.
Correct. Because the master key lives in a completely separate system. A key management service, or KMS. Think of it as a vault within a vault. AWS KMS, Google Cloud KMS, Azure Key Vault, HashiCorp Vault, they all work on this principle. The master key never leaves the KMS boundary. Your application sends data to the KMS and says, encrypt this or decrypt this, but it never holds the master key itself. It's like a bank safety deposit box. The bank lets you use what's inside, but you can't take the vault door home.
And these services are backed by specialized hardware.
Most of the major cloud KMS offerings are backed by hardware security modules, HSMs. These are tamper-resistant chips certified to federal standards, specifically FIPS 140-2 Level 3 in most cases. They're designed so that if someone physically tries to open the module, the key material self-destructs. You're not trusting software alone. You're trusting purpose-built hardware.
Yeah, that's a meaningful level of paranoia. Now, you mentioned key rotation in the episode title. Why can't you just create a good key and use it forever?
If only. NIST, the U.S. National Institute of Standards and Technology, publishes guidance called SP 800-57 that defines something called cryptoperiods. That's the maximum time a key should remain in active use. The logic is straightforward. The longer a key is in use, the more data gets encrypted with it. More encrypted data means more material for an attacker to analyze. And if a key gets compromised without you knowing, which happens, a shorter crypto period limits the damage. You're containing the blast radius.
So how does rotation work in practice? If I've encrypted millions of documents with one key, do I need to decrypt and re-encrypt everything?
This is the elegant part of envelope encryption. When you rotate the master key, you're only rotating the top of the chain. The cloud KMS generates new key material, but keeps all the old versions. Any new encryption uses the new material. Any old ciphertext still decrypts correctly, because the KMS knows which version of the key was used and automatically selects it. You don't touch a single document. The rotation is invisible to your application.
That's much less painful than I expected. What about access controls? Who's allowed to use these keys?
This is where key management gets interesting from a legal perspective. KMS platforms separate two roles: key users and key administrators. A key user, that's your application server, can request encrypt and decrypt operations. It cannot view, export, or delete the key. A key administrator can create, rotate, disable, and delete keys, but they may not be able to use the key for actual encryption. It's a separation of duties. Think of it like an ethical wall at a law firm. The conflicts department manages which matters can access which information. The litigation team uses that information. Neither can do the other's job.
Right. That makes sense. What about disaster recovery? What happens if you lose the master key?
Then every piece of data it protected is gone permanently. There's no backdoor, no recovery mechanism, no calling tech support. This is by design. The same property that makes encryption secure makes key loss catastrophic. So the mitigations are critical. Multi-region key replication. So if one data center fails, you have a copy. Deletion safeguards. AWS KMS won't let you delete a key instantly. There's a mandatory waiting period of at least 7 days during which you can cancel. And dual control procedures, meaning no single administrator can unilaterally destroy a key. You need 2 people to turn the key, like a nuclear launch.
That's sobering. Let me ask about a practical scenario. A law firm client terminates their contract. You need to delete their data. How does key management help there?
Great question. It's called crypto shredding. If each client matter has its own data encryption key, you don't need to hunt down every copy of their data across your production database, backups, replicas, and caches. You just destroy their DEK. Without the key, the encrypted data is mathematically unrecoverable. It's faster, more complete, and more audible than trying to find and delete every byte. For legal SaaS platforms that handle data subject access requests under GDPR or client offboarding, crypto shredding is one of the cleanest architectural patterns available.
Yeah, that's a powerful pattern. Any real-world cautionary tales to close on?
Adobe, 2013. They encrypted 153 million passwords using 3DES, an old algorithm. But the critical failure was using the same key for every single password. Identical passwords produced identical ciphertext. Attackers didn't need to crack the key. They just looked for the most common ciphertext pattern, assumed it was 1, 2, 3, 4, 5, 6, and worked backwards. 153 million accounts, and the key management was functionally non-existent. More recently, the Oric Harrington breach in 2023 exposed data on over 600,000 individuals and resulted in an $8 million settlement. The point is the same. Encryption exists, but the key infrastructure around it determines whether it actually protects anything.
Next episode, secrets management, API keys, database passwords, service tokens, the other set of keys that keep your entire system running.
Until then, I'm Alice.
And I'm.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.